Hi everyone, it's Ian here from Crack Maths and welcome to tutorial 45 on how to calculate the area of compound shapes. So this topic is all about finding the area of shapes and then adding those shapes together to find a bigger area. Okay, so before we begin, you're going to need to make sure that you know three key things, and that is 1, how to find the area of a rectangle, 2, how to find the area of a triangle, and 3, how to find the area of a circle. So the area of a rectangle, we know, is length times width. The area of a triangle is base times height divided by 2. And the area of a circle is pi r squared, or 3.14 times radius. If you need more work on these, remember you can visit tutorials 42 and 44 for more information on triangles and circles. Okay, let's quickly have a look at 3 of these shapes together so I can explain what compound shapes mean. So let's say I've got a rectangle here that is 2 meters by 5. The area of this shape is going to be 2 times 5, so the area of this shape is 10 meters squared. Now let's look at a triangle. Let's say I have this triangle here, which has a base of 5 and a height of 4. So the area of this triangle is base times height divided by 2. So 5 times 4 is 20, and then 20 divided by 2 is 10. Now let's have a look at this circle. So I've got a circle here, and it's got a radius of 2. Now, if I do the formula, which is pi r squared, I do 3.14 times 2 times 2. So 3.14 times 2 times 2 equals 12.56 meters squared. Now what I'm going to do is I'm going to merge these shapes together. So let's say I cut this circle in half and I stick it either side of the rectangle. Now I'm going to put this triangle on top of the rectangle. So as you see now, I have one big shape. Compound shapes is where you're asked to calculate the area of shapes that look something like this. They might look like this or they might look different. But the key is, can you divide these shapes back into the shapes that you know? Okay, so I know that the area of this shape is going to be 10 meters squared for the triangle plus 10 meters squared for the rectangle plus 12.56 meters squared for the circle. Okay, so that gives this shape a total area of 32.56 meters squared. Okay, let's go have a look at some examples. So here we have question 1. Question 1 says, a shape is made of a rectangle with length 10 centimeters and width 6 centimeters. On each of the 6 centimeter sides, there is a semicircle. What is the total area of this shape? Okay, so this is a very common shape that we see in functional skills maths. It's basically the shape that looks like a running track. So they're asking us, what is the area of this shape? Have a quick look, see which shapes you can see within this shape, and can you work out the necessary dimensions required? Okay, great. Hopefully you saw that if we cut off both the semicircles and stick them together, we have a circle with a diameter of 6 centimeters. Then, what's left in the middle is a rectangle with a length 10 centimeters and a width 6 centimeters. If I now use the formulas, I know that the area of the circle is pi r squared, so I know that the diameter is 6 centimeters, which means the radius is going to be 3 centimeters. So I'm going to do 3.14 times 3 times 3, and that equals 28.26. And now for the rectangle, I'm going to do length times width. So the length is 10, the width is 6, 10 times 6 equals 60 centimeters squared. So now I've got 28.26 centimeters squared for the circle, add the 60 centimeters squared for the rectangle, so the total area of this shape is going to be 88.26 centimeters squared. Okay, let's have a look at another question. Okay, so in question 2, we've got this shape here that looks like a house. First of all, let me read the question that goes with it. So it says, a shape is made of a triangle with a base 12 millimeters and a height of 9 millimeters. On the base, there is a rectangle whose length is equal to the base of the triangle and whose width is equal to the height of the triangle. What is the total area of this shape? Ah, okay. Well, it's kind of made it pretty clear in the question, actually, that this shape is, as you can probably see, made from a triangle and a rectangle. So we've been given the information for the triangle. We know that the base of the triangle is 12 millimeters and the height of the triangle is 9 millimeters. Now, this is very common, actually, where we'll have a look at this rectangle, where measurements of the two shapes line up. So we can see here that the triangle fits perfectly on top of the rectangle, which means the width of the rectangle is the same as the base of the triangle. So we know if I take away this rectangle here, I can put down that the width the length of the rectangle is 12 millimeters. Now, the other dimension of the rectangle is the same as the height. So if this is the 12 millimeter one, then it means that the height is going to be 9 millimeters. So that means we've got a triangle with base 12 millimeters and height 9 millimeters, and a rectangle with length 12 millimeters and height 9 millimeters. In rectangles, we can use different ways to describe the lengths. You'll notice that I keep flitting between width, height, length, and I actually mix them up sometimes as well. That's because the dimensions of the rectangle kind of do change their names, but the important thing is that we know that for the area of a rectangle, we have one dimension multiplied by the other. So whether we're calling the height, or the width, or the length, it still means that we've got one dimension multiplied by the other. Okay, so let's do the triangle first. So the triangle is base times height divided by 2. So we're going to have here 9 times 12, which gives us 108 millimeters squared. And then we've got to divide that by 2, which gives us 54 millimeters squared. So the area of the triangle is 54 millimeters squared. Now we need to do the area of the rectangle. So the rectangle is 12 by 9 as well. So 12 times 9 is 108 millimeters squared. And now because this is a rectangle, we don't have to halve it by 2. So what we can now do though, is we can add these together to get the total area of our compound shape. So 54 add 108 equals 162 millimeters squared. Aha, right, so in practice question 3 we have a different type of compound shape, and in this shape it's actually one where we're removing a part. So let me first read the question and then we'll have a look. A shape is made of a triangle with a base 9 centimeters and a height 6 centimeters. Cut out of the triangle is a square with a side length of 3 centimeters. What is the area of the remaining shape? Okay, so this time it still falls under compound area, but instead of adding the areas together, we're actually going to be taking away. Because what we have is we have this triangle, and then we're removing a square from the middle of the triangle. So the area of that square is no longer going to be part of that shape. You could kind of imagine it as if this was like some kind of triangular door and there was a window cut in. The amount of paint you would need to coat that wood, well, you wouldn't need the paint to coat that centre window because that's not going to be painted. So you're actually going to need less paint than if you were covering the whole shape. So always think to yourself, am I adding this shape on or am I removing the shape? And largely, if that shape exists entirely within another shape, then it's likely that you're going to be removing it. Okay, so first of all, let's look at our triangle. Very straightforward. We've been told the base, we've been told the height. So we've got a base of 9 centimeters and a height of 6 centimeters. So 9 times 6 is 54. 54 divided by 2 equals 27 centimeters squared. Now let's look at the window. Well, or the box, the square. So it is a square. So they've only actually told us one dimension because we're meant to know that squares are the same length all the way round. So if it is a square with side length 3, that means that the other side length is 3 as well. Now a square is a special form of rectangle, so we're just going to do side times side, length times width. So 3 times 3 equals 9. So now we know that the area of the square is 9 centimeters squared. So we've got the area of the whole triangle is 27 centimeters squared, and the area of the square is 9 centimeters squared. Now all we have to do is take the square away from the triangle. So 27 take away 9 equals 18 centimeters squared. Perfect. Okay, great. If you want to stop there and have a go at the practice questions, there's loads of these over at Crack Maths under tutorial 45. If not, stick with me and we'll have a look at a scenario question. Okay, so here is a scenario question, and we've got a shape down here which we can actually see is quite a classic shape that we often see in functional skills questions as well. It is the L shape. Okay, so instantly we can look at this L shape and see that it's probably going to be divided into two rectangles. Okay, if I'm just going to put a line down the middle of that L shape to start off with, just so that we know that that's coming. Now, let's have a look at the question. It says here, Maria has a house with L-shaped rooms. One section of the room is rectangular with dimensions 4 metres by 5 metres, and the other section of the room is a rectangle with dimensions 3 metres by 6 metres. What is the total area of the room? Okay. Right, so here we go. Let's put this information on here. I can see here that I've got one, which I'm going to label 4 by 5, and I've got the other, which I'm going to label 6 by 3. Now, this is interesting here because this is actually very straightforward. We're going to work out both of these rectangles by simply doing length times width. Okay, so let's do that first, actually, and then I'll come back to the question to talk about the shape a bit more. So if we do 4 times 5, that's 20. So I'm going to put 20 metres squared here. 6 times 3 is length times width for the other one. So that's going to be 18. 20 add 18 is going to equal 38 metres squared. So this room is going to have an area of 38 metres squared. Okay, but before I move on, I want to just have a quick talk about some of the other dimensions of this room. So if I see here, I've written all the dimensions on now. Can you work out for me how long this wall would be? So how long would the wall at the bottom of the shape be? So what would the total length of that wall be? It's important because sometimes this would be the piece of information that we were given as opposed to, say, the 6 metres. And then we'd be expected to be able to work that out. Another thing we might think about, how much is this little part of a wall going to be? Because it might be that we're given that length over the 3 metres. Okay? Before we go, let me just show you one more shape, and I want you to see if you can work out the missing lengths. Okay, so here we go. We've got the same shape with slightly different lengths. So in this question, what I want us to do is, I just want us to see if we can work out the two missing sides. Now, first of all, let's have a look at the missing horizontal line that touches the 6 metres. Okay, so we know that the shape along the bottom has a length of 8 metres, and this shape along the top has 2 metres. So that means that because these are rectangles, we know that essentially the journeys are the same because they're right angles, so they're going to be going in the same direction. So we know that if that's 2 metres along the top, and the whole length is 8 metres, that this missing line would have to be 6 metres. Okay, now what about this missing vertical line? So we know that the shape is 10 metres high, and we know that the other rectangle, the second rectangle, is 6 metres high. So we can see that that little bit there is going to have to be the remainder of what takes us from 6 up to 10. So that will be 4. Okay, great. Anyway, if you need more practice on this, there's loads of questions available at crackmaths.co.uk, and I will see you in another tutorial. Okay, bye.